in token bucket algorithm, what happens is we have a bucket, let's say we have a bucket like structure and we have various tokens inside the bucket. Hmm. Let's say this is a token and we have tokens inside bucket. We know that a particular request always comes from a particular IP address, right? So let's say we have an IP address. I have taken a random non-invalid IP address, and this IP address, just for example, this IP address is sending a request to our server. So let's say this IP address is requesting our server. We have our server right here, and this IP address has sent a request to our server. What this server now will do is, what we will do is, this request first checks if we have tokens available in our bucket. So basically, each IP address gets allocated a single bucket, and a request coming from the IP address must go to the bucket, collect a token, and only then it will be passed, or only then it will be allowed to pass through. So if we have a request coming from a particular IP address, the request goes to the bucket, checks for tokens. If token is available, it takes one token along with it, or like a token is allocated to the request, and the request will then successfully pass through for further processing. But let's say we have run out of tokens. We had number of tokens, but let's say a lot of requests have come through and all the tokens got used. So we have run out of tokens. Now that a request comes, now if a request, another new request comes to our server, now if a new request comes to our server, what will happen is this request will go to the bucket, check for tokens, but it will see that we do not have the required number of tokens left. Since we do not have any tokens left and the request must take a token to be passed further, so this request cannot pass further, and basically this request gets dropped. So this request cannot pass further and this request will be basically dropped, and this request is not processed. This is basically how rate limiting or token bucket algorithm for rate limiting is working. So we'll have particular number of tokens. Let's say, let's take a practical example. Let's say we have 10 tokens maximum, which is the maximum capacity of our server or our bucket. Let's say we have 10 tokens, which is the maximum capacity of our bucket, and we have a token refill rate of one token per second, because we also need to refill the bucket, right? Because our requests keep on coming to the server and we need to serve each request a token. So we must refill the token as well. So we have 10 tokens max. Now let's say our bucket is full of tokens. So it has reached its maximum capacity. Now a request comes from a particular IP address, checks for the number of tokens. It says the bucket has tokens, so the tokens, one token will be allocated to the request, and the request will successfully pass through. Now that we have allocated a token, we must reduce the number of tokens from 10 to 9 because we have used up a token. Now let's say another request comes through. Another request comes through to the server. It again goes to the bucket, checks for tokens, takes one token if it is available, and passes it. Again, we have to deduct the number of tokens available. So now we have 8 tokens. Similarly, let's say at the same instant, 8 requests come through. We are talking about a particular time instant. So let's say 0th second, 8 requests come through, and all these 8 requests will be allocated one token each. Therefore, all the 8 requests will pass since we have enough number of tokens. Now what happens is we have 0 tokens left. So we have basically run out of tokens. Since we have run out of tokens, what will happen is, now that another request tries to come to our server, if we have another request which is coming to our server, this will go to the bucket, will check for number of tokens available. Now it says that we have no token available. So since we do not have any token available to allocate the token to a request, this request cannot pass further and it will be dropped. In this manner, we have maintained the limit of 10 requests per second, and if any request crosses this limit, After 10 requests, since we do not have tokens available in our bucket, then the request will be dropped or queued for later on. Now what happens at the next second? Let's say 1 second has passed. Now we are talking about the first second. What happens in the next second is we have a token refill rate of 1 second, right? One token per second. So one token comes into the bucket. The bucket gets refilled with one token instead. Now it does not have zero tokens. We refilled the bucket with one token. So again, now our request will come, take the token, and again pass through. But again, at the same instant, we have now zero tokens left for the first second. Now, if again a request comes through, we do not have the required number of tokens to serve. Therefore, the request will be dropped again. In this manner, we have token bucket algorithm for implementing rate limiting. Now, let's look into a practical example. So here we have our client. The client is not of our concern here, and here we have the server. Inside the server, I have a microservice architecture containing basic services for now, like the auth service, listing service, notification, etc. These are taking care of various kinds of requests, and this is the gateway. So let us quickly look through what I'm talking about right here. We have an API gateway at our backend, and then we have various services. For example, firstly, microservice architecture is basically we have numerous services or numerous servers, we can say. So we have various different servers. One server is looking after authentication. One server is, let's say, looking after notification service. One server is looking after, let's say, chat service. And one is looking after listing service, let's say. So these are various different servers. Each service is basically a server that we are seeing. So we have four different servers, let's say, in our backend, and each server is looking after a particular task or a particular function. Now, when a request comes from the client, it comes to the API gateway right here. It comes to the API gateway, and the API gateway now deals with the request. What happens is this request comes to the API gateway, and this API gateway will decide whether this request needs to go to the authentication server or the notification server or chat or listing. For example, let's say the request that we have received was for registration. So a register request comes to the API gateway. The API gateway says that, okay, it is a register request. It needs to go to the authentication server or the authentication service. So the API gateway send this request to the authentication service. Let's say we have another request for a chat with a particular user. So a chat request comes to the API gateway, and this API gateway again sees that, okay, this is a chat request and needs to go to the chat server. Therefore, this request will be handled and will be sent to the chat server or the chat service, and this request will be handled via this server. In this manner, the API gateway is responsible for distributing the request that is coming from the client. So in a manner, we can say that the load the load of requests which is coming from the client to the server gets equally distributed, or let's say not equally but gets distributed across various services. So in a way, the API gateway that we have also acts as a load balancer, because this is balancing the load among various servers that we have. And we need to implement rate limiting for like we can implement rate limiting for these services as well, but it is very important to implement rate limit for our API gateway. This is because the API gateway is the first point of contact for our backend rate. Every request which is coming from the client is first handled in the API gateway. So if the API gateway goes down, any request would not be allocated to its particular service, and basically our whole backend will go down. So we need to limit the number of requests which are coming to the API gateway. Otherwise, the server might crash for this as well. So for the API gateway, we have the rate limit right here. As you can see in the middleware folder, we have a file called ratelimiter.middleware.js, which is looking after rate limiting of the API gateway. This is the code for it. And as I've mentioned, I have defined the maximum number of tokens. It can be defined right here. Like I've defined the maximum number of tokens for my bucket as 10, and the refill rate is 1 token per second. So every second, 1 token comes to the bucket. And as I've mentioned, each IP address is assigned its particular bucket. So different IP addresses will have their own bucket. This bucket that we have talked about, each IP address has its own bucket. So different IP addresses will have different buckets, and each bucket has a maximum capacity of 10. So at a second, only 10 requests will be able to be processed, or 10 requests will pass through. Then we can see that we have calculated the time elapsed, and accordingly we refill the bucket. And then we have the deduction logic where we deduct the number of tokens. So if we have an incoming request, it will hit the middleware and it will see if tokens are available, then the tokens, 1 token will be deducted and it will be passed on. But if tokens are not available, then this part will be hit, and it says, basically it returns an error code of 429 which says too many requests, which means that the request has hit the rate limit, and the user must try again later. So we are dropping the request here and we are sending an error code of 429, which says too many requests. Now we have built this rate limiter. Now let's test out this rate limiter. So to test out this rate limiter, we will use something known as autocannon. So in our console, let's say we have 10 connections representing 10 different users. But since I am testing it from my local machine, all the 10 connections will be from the same IP. So it basically will have only a single bucket or a single user. But still, let's say we have 10 connections and we'll be sending, let's say, 100 requests to our gateway. And the port in which our gateway is running is port 3000. So our gateway is running at port 3000, and the API route or the endpoint which we will hit is the health endpoint. So you can see that in the index.js file, we have this health endpoint, and we can hit this endpoint to check if our gateway is running or not. So we have this simple endpoint which we will hit, and let's see what happens. First, let us go with 10 requests. Now we know that since we are sending this request from the same IP, so all the connections will only be allocated a single bucket. And in single bucket, we know that the maximum capacity is 10, right? So at a particular second, only 10 requests will pass through. So let's see what happens here. So here we can see that 10 connections has been established, but it's basically the same IP. So we'll have only one bucket. Now we have 10 timeout errors. Gateway is just running fine. So let me see. Okay. Let's run this command. We have 10 connections and we have 10 requests which we will be sending to our gateway. Okay. So we can see that 10 connections has been established, but it's basically the same IP address. So we'll only have one bucket, and we can see other stats right here. But at the end, we can see that 10 requests have been processed and the total time which was taken is 1.1 second. So at that particular time instant, we have 10 requests which had been sent to our server, which is the gateway. And let's see what was the output. So we can see that we got a 200 response, which means that the gateway was just running fine. Let me clear the console and show it to you once again. So if we run this command again, we have 10 connections and 10 requests. First of all, let us run the gateway. Okay, gateway is running fine on port 3000. Now let us run our command. Okay, after running our command, we can see that 10 requests have been made, and we can see the output of those requests right here. So we have hit the endpoint and we have got a response of status code 200, which means that the connection is just fine and we are the gateway is working fine. And all the requests which we have hit have been executed correctly or has been passed. Now let's exceed the limit that we have set. We have set a limit of 10 requests, right? So let's send 20 requests now. From 10 connections, if we send 20 requests, ideally what should have happened is, since we have 10 different connections, if all 10 different connections were from different IP addresses, then all these 20 requests would have been passed, because at a time, let's say one IP address is sending two requests. So from 10 connections, we have 20 requests. Now at a time instant, if two requests are being sent, this is under the limit. So this would have been passed. But since we have all the connections from the same IP address, we only have one bucket. So we have a limit of 10 requests in our single bucket that we have. When I execute this command, we can see our response right here. So from these 10 connections, we have sent 20 requests. And what is the output of those 20 requests? We can see that we have got 10 2xx response, which means we have got 10 responses which are of the house 200, or like 200 house, or we have got okay responses for 10 requests. The other 10 requests, we got non 2xx response. Let's see what the response was. So right here, you can see that first 10 requests, for the first 10 requests, we have got a status code of 200, which means that the gateway was just running fine and it was allowing the requests. So we got a status code of 200. But as soon as the 11th request arrived, we hit our rate limit. And mind you, since all the requests went under a second, so the bucket was not able to refill itself. It only had 10 tokens. Since the bucket was not able to refill itself, the 11th request, and from the 11th request, the further requests which came to our gateway all got a status code of 429, because here we are returning a status code of 429, which means too many requests. In this manner, our rate limit, we can confirm that our rate limiter is working just fine. For example, if we test it with a bigger load, let's say we have 100 connections, but the number of connections do not matter here because they are from the same IP. But still, we are sending 1,000 requests from, let's say, 100 connections. Okay, it took a bit of time to process because it was a lot of requests. Now we can see that we have passed 1,000 requests to our endpoint, and the response that we got is 22xx response and 957 non-2xx response. Now you would argue, why did we get 20 okay responses? Because we had a rate limit of 10, but why did we get 20 okay responses? This was because all the requests did not get processed at the same time instant. We can see that we it took a lot of time. It took more than 1 second to get processed, right? So we had multiple seconds. I am assuming we had 2 seconds for which the requests were processed. That is why we had only passed 20 requests, and the rest of the requests were discarded. So in our gateway, we can see that we are getting 429 status codes for a lot of requests. In this manner, the rate limiting is working. In this manner, the rate limiting is working in our application, and that is how we can test out our rate limiter.